Okay, so here's the next function. So you take a look here, what we mentioned a moment ago. Now I'm gonna break it down. Now this is quite a bit, but we'll go into what I mean about when you saw it in the graph, like how they make that curve. This is where it exists. I'm gonna show you how it works. So P of T is, of course, T is age. P is a maximum probability of an individual that can remember some random memory. This is not based on attention. It's not based on some kind of like focus or something that you have had. It's just a random piece of memory. What's the probability of remembering that particular memory? Well, you come in here and you say, okay, here's some A, which is the individual's cognitive capacity. The default is 1.0 because we assume that, you know, everyone's relative. We'll just say everyone's average 1.0. It changes per person, but we'll leave it at 1.0 for simplicity. And then here you have T again, which is just the absolute value of time, and then plus 2. Now, why did I put plus 2 here? Because I wanted to be able to shift it 2 years for fluctuation. Because for some odd reason, when a child is learning between the ages of 0 and 2, they have such a huge fluctuation. And if you look at the actual Euler's number, you can see the kind of oscillation happening. So we use a plus 2 to kind of help with that dampening a little bit for the first 2 years, which makes sense because there's a lot of going on in the first 2 years. So that's the top part here. So this whole section here is the growth rate, or the growth. I show it here. The growth rate of memory capacity. All right. And then over here is more like a reduction of the memory capacity. So over time, you don't remember as much. And this function will govern that. We'll talk about that in a second. So in here, you have this section below here. This is, you know, the denominator of this Euler number. And you say, well, what is that? Well, 0.75, again, the Euler number, T to the cotangent of 1.20. So, you know, okay, what does this mean? So 0.75 is a factor in terms of 9 months. So, of course, the graph is by years, and everything within years will be in decimal values. 0.75 would be 9 months, of course, because there's been some kind of a little bit of research. I'm not exactly sure, but I need to go back and just keep working on this. But there's been some research on how 9-month intervals have been used to construct how our brains and how we function. And if you look at in this whole function here is based upon a Fibonacci sequence. It kind of resembles a Fibonacci sequence, whereas you're looking at how does the Fibonacci sequence work, you know, 1, 1, 2, 3, 5, 8, 13, and so forth, right? Well, if you were to take the end result and multiply by 0.75, which is a 9-month period, you get a different factorable value of like 9 months, 18 months, 27 months, 4.5 years. I have to look back at the numbers again. But those numbers correspond to, you know, you have these different development sections in your life when you were like 9 months old, when you were at 18 months. So when you're at 18 months old, and when you're at 27 months old, and when you're at 4 years old, and when you're at like, you know, teenager, like 13, 14, when you're at like 21, then when you're at like 35 or 30, somewhere between 35 and 39, then of course 65, and then so you have these different like frames that happen. I used to think it's every 7 years, but it seems to be like it happens every couple of these based on these Fibonacci kind of sequence numbers. So I took that function and kind of constructed in the denominator of this Euler number, right? And this of course here is 0.75 to reflect 9 months, but then 1.2, how did I get this number? Well, I said, well, if you think about the base of 1 is just 0, and then you take the 0.2, which is the maximum peak age, and you say it's 20 years old. I mean, you can change this. You can put in 21, 25, 30, whatever you want to put in here. But given that's the peak age for our standard consensus, I put in 1.2 to reflect 20 years, as you can see here. And what that does is it gives a growth rate that happens to correspond to a time around 20 years, where is the maximum point on here. Now, you take the dot product of this by this portion, which is just your age over 220. How to get that? I said maximum heart rate. Like, why did I use this number? Well, I try to get trying to figure out how do I get a ratio to best reflect a depreciation of cognitive performance. And I thought, well, I assume that the heart rate is at some level corresponds to the depreciation of how the brain works. And I remember there was a number 220 that we used to use as a rule of thumb to look at. 220 is the maximum heart rate that you can take from, even though there's been a lot of debate by that number. You subtract it from the age, and then that would give you your maximum number, right? I said, well, what if I took the actual age over this number to give me a ratio of depreciation based on that, and then every year you go up, it begins to become lower and lower and lower depreciation value, because this is a decay function. So I took these two pieces here, multiply them out together by some value A, and I get this pretty nifty graph to help me look at where this person could be. Now, of course, you might do some cognitive performance to apply it here. So, for example, on an average person, if someone happens to be smarter based on their exam or something that you may take, you can say, okay, well, relative to other people, they're 1.1, 1.2. And of course, that increases the probability of, remembering some random memory based upon that cognitive performance. This function is something that I created to help with machine learning and to help understand the capacity of some type of long-term memory and why these functions actually work. Now, you don't need to actually use this in there, but you can look at how this corresponds to a little bit of how cognitive performance works over a long period of time. Because a lot of times we look at things instantly, but how does this function over a period of time? How does the growth rate, how does the brain begin to develop, and the life cycle of a machine or a life cycle of a particular agent?